Welcome to another Audio Cultures workshop video, improving your audio and finishing the mix. Understanding gain structure. The signal level meters enable you to measure the average and peak levels of the signal you are recording. Signal levels are measured in decibels or dB. The maximum level that can be recorded in a digital system is shown as 0 dB. All levels below this are negative decibels. The solid part of the meter smooths out the rapid fluctuations in signal level to show the average. The instantaneous peaks are shown with the green line that floats above the average level. There are several meter options in the Pro Tools preferences. The RMS or root mean squared option shows a slow-moving average plus instantaneous peaks above. The difference between the average or RMS level and the peak level is called the crest factor. The crest factor is different for different sound sources. For speech, the crest factor is usually around 12 dB. For raw musical instruments and sound effects, the crest factor may be as much as 20 dB. When recording, you must ensure that the peak level does not hit 0 dB, as this will result in unpleasant distortion. The red light at the top of the meter will hold when you hit or exceed 0 dB. You'll soon learn that it is difficult to predict how high the peaks of any sound will go. Therefore, you should leave a margin of error known as headroom. It's advisable to leave at least 8 to 10 dB of headroom between the signal peaks and the maximum 0 dB full scale. When recording speech, this means that the average level will be around minus 20 dB. For more dynamic sources, set the average a little lower and keep your eyes on the peak to allow 8 to 10 dB of headroom. Setting the gain structure. In your projects, you will probably be using material recorded with a portable recorder. Once imported and placed in an audio track, you can see the average and peak levels. A good approach is to choose a foreground element, such as a voiceover, and use clip gain to set the RMS or average level so that it sits around minus 20 dB. It will move above and below this level, but make sure the peaks don't go above 0 so that the red peak light comes on. On the 25th of January, the first 4 cases of coronavirus were confirmed in Australia. By March 24, we were all told to stay at home. No travel except for essential purposes. For many of us, normal life came to a halt. Gain in the mix window is additive. Adding 0 dB with the channel fader means no change in level. Adding 6 dB with the channel fader and 6 dB with the master fader results in an overall increase of 12 dB measured in the master fader meter. Reducing the channel fader by 6 dB and boosting the master fader by 6 dB results in minus 6 plus 6 equals 0 dB or no change in level. If our foreground audio track is at minus 20 dB with the channel and master faders both at 0 dB, the master fader level meter will also show minus 20 dB. Now, as we add additional mid-ground effects and background atmospheres, the combined level of these tracks will increase the level in the master track, but hopefully they will never reach 0 dB. Every time we move to a new foreground sound, we should check that the average level for this sound is around minus 20 dB, and compare the loudness to our initial reference foreground voiceover track. No travel except for essential purposes. For many of us, I miss the train ride into work each day. A space of social control. A space of social control. A space of conformity. The wasted hours in transit. The wasted hours in transit. The endless miles up and down the delays, cancelled service, the mad rush to escape the crowds of Central Station. The mad rush to escape the crowds of Central Station. The pitiful attempts at social control and coercion. The pitiful attempts at social control and coercion. When travel restrictions are lifted, I'll be back on the train. Back in the zone, enjoying the reveries of train travel. On the 25th of January, the first ride into work each day. When travel restrictions are lifted, the rate of infections is reducing. Kids are returning to school. There's a glimmer of hope that life will return to normal. On the 25th of January, the rate of infections is reducing. Now, mid-ground effects and music and background atmospheres can be set to sit behind the foreground track in level. I suggest using clip gain to set the levels of these sounds, as this allows the channel faders to be used for more general adjustments. As you add more sounds, watch the master fader meter to make sure it does not hit the maximum 0 dB level. Luckily, the internal mix buses in Pro Tools have a lot of headroom above 0 dB, but the output at the master fader is limited to a maximum level of 0 dB. Improving your audio. There are several things you should listen out for that can really impair the reception of your audio. The first is clicks and abrupt edits. Make sure you use the fade tool to place smooth transitions at the tops and tails of your clips. When editing, I use the Smart Tool mode. The Smart Tool is selected by clicking the bar above the Edit tools or typing Command or Control 7. With the Smart Tool selected, we hold the cursor at the top left or top right of the clip until the Fade tool is displayed, then click and drag to make a fade. The default fade shape is linear, but other fade shapes can be selected in the Pro Tools preferences. While you have the fade tool ready, you will also want to use it to create crossfades between adjacent clips. Hold the mouse pointer at the bottom of a join between clips until the crossfade tool is displayed. Click and drag to make a crossfade. Use the Equal Power crossfade option for seamless fades. Smoothing clip transitions is the first step in dealing with the second issue for improving audio. The ear is very sensitive to change, so eliminating abrupt changes in level is critical. Only use changes in level for dramatic effect at important transitions in your program where you choose to activate the listener's attention. To make sure you do not have any unwanted abrupt changes in level, listen carefully through the program with an ear for the overall mix rather than focusing on foreground elements. When you spot something that needs changing, start by getting a point of reference from your initial foreground element as discussed above. This is where memory locations are essential, as they allow you to jump through the program to compare levels. The final improvements you can make are to remove unwanted low-frequency noise that often gets recorded in outdoor locations. For this, we will use the EQ3 one-band equalizer plugin. In the mix window, we click on an empty insert point in the track we aim to change. From the plugin menu, select EQ, EQ3 one-band. This plugin offers 5 different filter types that allow us to modify the frequency content of our audio. The filter we are going to use is called a high-pass filter. Click this button to select it. We can modify the slope or rate of cutoff, and we will choose -12 dB per octave. Now, While playing the audio, increase the frequency until the rumble and noise is removed, but the audio that we want is not affected. Slide it up too far and you will hear the sound become thin and bodiless. Slide the frequency down to let your wanted sound pass through. A high-pass filter passes the high frequencies and stops the low frequencies. It's sometimes called a low cut for that reason. The EQ3 one-band is also useful for balancing the overall bass against treble or low frequencies against high frequencies. Our ears treat 1 kHz as the middle of our hearing range between 20 Hz and 20,000 Hz. Frequencies below 1 kHz are low and those above are high. The low shelf and high shelf filters allow us to boost or cut the lows or highs. If your recording sounds too bright, choose a high shelf and reduce the gain. Adjustments in the range of less than 6 dB will usually be sufficient for good recordings. If, after using the high-pass filter, there is still too much low frequency, or your recording is boomy or bassy, use the low shelf filter and reduce the gain. No travel except for essential purposes. Delivering your mix at the required level. The delivery specifications for the audio postcard project specify 256 kilobit per second stereo MP3 with a mix level of -16 LUFS and a duration of 4 minutes. Let's start with the mix level. -16 dB LUFS stands for -16 decibels, loudness units, referenced to full-scale level of 0 dB. Loudness units are a measure of perceived loudness used to compare program level in broadcast environments. A loudness unit meter is similar to the RMS meter we use on the channel and master fader, but it gives a more accurate reflection of how we hear. It is the measurement standard used for both broadcast and digital streaming services. The Audio Engineering Society recommend setting the loudness level of mixes targeting streaming media to -16 dB LUFS with a peak level of -2 dB. To make this measurement, we need a special meter, but we also need to control the dynamic range of our mix so that it does not exceed -2 dB. For this, we need a dynamic range control device called a program limiter. Luckily, Pro Tools comes with a plugin that combines a loudness meter with a limiter. We insert this on our master fader. Click on an empty insert point in the master fader and select Multi-Channel Plugin, Dynamics, Pro Limiter. To use the limiter, select Auto Release, set the character control to 0%, set the ceiling level to -2 dB, this is the maximum level that the signal will be limited to, play the audio and watch the meter. The integrated level, which averages out the loudness over the whole program, is the measurement we need to watch. But you might also want to check the variation in level shown by the graph at the bottom. If you have a quiet section, consider if it needs to be boosted, or if it is just a brief section where there is no foreground element. Once you have played through the program, you will have the overall integrated loudness displayed in LUFS. Mine is showing about -23, so in order to boost it up to -16, I lower the threshold by 7 dB, and this will automatically add 7 dB of gain. Whenever the input goes above the threshold, the limiter momentarily reduces the gain to keep the signal peaks under -2 dB. Play through and make sure your final integrated level is -16 dB LUFS. Final bounce and delivery specification. Now we are ready for our final bounce. We must first make a timeline selection that includes all the audio regions in our project. This should be close to exactly 4 minutes in duration. If you have your memory location set up, you should be able to click on the Start marker, hold down the Shift key, and click on the end marker to make your selection. Now select File, Bounce to Disk. Your bounce source is the main output. You will bounce both a high-resolution WAV file and an MP3 for delivery. In a professional context, you will always deliver WAV files. MP3 are only for quick and easy sharing. The file format is interleaved. The bit depth is 24 bits. The sample rate 48 kHz. Make sure your bounce has an appropriate name, including your name and the title of the project. The default destination folder is the Bounced Files folder in your Session folder. Click Add MP3 and then click Bounce. Select a constant bitrate of 256 kilobits per second as specified in the task description. Enter ID3 tag, title and artist details and click OK. To check your work, load the bounced WAV file into a new Pro Tools session. Check the waveform to make sure it looks OK and listen back while checking the meters. Also, try playing back the MP3 file on various playback systems. Try your computer speakers, good headphones, your telephone earbuds, and anything else you can find. Ask a few other people to have a listen to get some feedback. If it sounds reasonably similar on all systems and your friends and family like it, you are ready to submit. That concludes this workshop video. Thanks for watching.